your mean, mean pride. Though his mind is not.
Okay, hello, grade 11s from Nelson. So this is Mr. Quenneville, and I'm going to take up a few of the questions from Thursday's homework for your MCR3U course. So this all comes from your textbook, page 130. We're going to start with number 16. Once again, just to remind you, that's the textbook we're using. Okay, everybody has one. And we're going to deal with page 130 here. Number 16. Okay, so let's read it. Here we go. So gardening, we've got this rectangular lawn and it measures 7 meters by 5 meters. And they give you the diagram on the right. Then they say a uniform border of flowers in blue is to be planted along 2 adjacent sides of the lawn as shown in the diagram. So if the flowers, so the blue, the flowers that have been purchased will cover an area of 6.25 meters squared. How wide is this blue border of flowers? Okay, so we've read the question. I probably would reread it to really understand what they're saying, what they're asking for. So let's start looking at it. And first off, we do have a rectangular lawn, and we're going to need to deal with areas. So we're going to need to remember that the area of a rectangle is defined as follows. So the area is the length times the width. So probably a good idea to set up some let statements for this question. And they look like this. So we're going to let A be the area, let L be the length, and W be the width. Okay? Okay, so we've got this rectangular lawn here that measures 7 meters by 5 meters and a border made up of flowers. So let's actually draw that diagram on our sheet. It's always good to have a diagram to visualize and to help place information for solving these types of problems. So it's just a sketch, you don't need a scale. Okay. Okay. First off, we'll let this be the 5 meter by 7 meter rectangular area. Okay, the lawn. And then we're going to have this border of flowers that you're going to want to put along the outsides of one length and one width. Okay, so I mean in here, you're putting flowers. Okay, now there's some keywords in the word problem. So here it says, a uniform border of flowers. Well, the word uniform, okay, it means it's the same so this border width of flowers all along the top and along here is the same. So we need to introduce a variable because they're not telling us what that border width is, and in fact that's what we need to solve for. So we need to introduce a variable. Let's do that. And our favorite variable is x. So that width there, because it's uniform, x exists as a width for that border along here as much as it exists along here. Okay? Take a close look at this. We've got one rectangle that's 5 by 7. And we have this other rectangle bigger one, and his dimensions are 7 plus x and over here 5 plus x. Okay? So the inside rectangle is the lawn, 5 by 7, and the outside part is a bigger rectangle, and its dimensions are now 7 plus x and 5 plus x. Okay? Okay, so let's not forget, we've introduced this x variable. Let's use a let statement. Let x be the border width. Okay. Now, we haven't actually really done any math, any calculations, so let's start rereading the question and seeing where we're going to move into our calculations. So we've got this rectangular lawn measures 7 meters by 5 meters. Okay. The uniform border of flowers is to be planted along 2 adjacent sides of the lawn as shown in the diagram. So we've got our diagram. If the flowers that have been purchased will cover an area of 6.25 meters squared, how wide's the border? So we've got these areas. We've got 2 rectangles. It's time to put together an equation. It's going to be a quadratic equation. Okay. And we're going to have to solve this quadratic equation. And when we solve it, we're just going to be solving for the value x, which is going to give us our border width. So let's have a look at the question here. Okay. First off, let's call this area in here area 1. Okay. And the area of the whole thing, let's call it area 2. So area 1 is the inside rectangle, area 2 is the whole thing. Now, this is where you got to understand this. The flowers here, the area of the flowers is the following. The area of the flowers, you have to take the entire area, A2, and subtract away area A1, and you're left with the area of the flowers. Okay, maybe you want to call the area of the flowers area 3. Okay, so area 3 here is the total area, area 2, subtract away that smaller area, A1. Okay, area 3, the flowers, let's look at the question. If the flowers that have been purchased will cover an area of 6.25 meters squared, well, area 3, okay, is your 6.25 meters squared. And then area 2, okay, well, an area for a rectangle is length times width. Look at area 2, it's the whole thing. So what's the length of area 2? The length of area 2 is 7 plus x. Okay, and the width of area 2 is 5 plus x. Right? That's just length times width for this big rectangle that encompasses the lawn and the flowers. And then area 1, okay, again, another length times width area because it's a rectangle. Area 1 measures 5 meters by 7 meters. Okay, and again, we got length times width. All right. So we're building our equation. Let's continue building the equation. Here's what's going to happen. We're going to drop the units and just work with our numbers. Okay. We have to foil. These two binomials, and we're going to get 35 plus 7x plus 5x plus x squared, and right here from this we get minus 35. Okay, let's collect like terms and simplify. Alright, so we got 6.25. Okay, the two 35s will cancel, and we're going to get 12x plus x squared. Okay, I'm sending my 6.25 over this side. That has this effect. You're left with 0 here. I'm going to switch x squared and 12x because I like having it in descending degree. X squared plus 12x minus 6.25. Okay, this is good. We're down to a quadratic with 3 terms. And we have tools to solve this. What tools do we have? Well, let's think about our tools first. Well, we could complete the square. We could partial factor. We could use the quadratic formula, or we could factor. Now, if we were to complete the square, completing the square gives you the maximum of this quadratic. We don't want the maximum. We want one of the solutions, one of the roots. Okay, we could partial factor. Yet again, we don't want that. That would just give us a maximum. We are then left with two choices, and those choices are to either factor this, okay, or use the quadratic formula. And guys, you're going to use the quadratic formula. So let's use the quadratic formula and solve this. Okay. Now, in this equation, for your quadratic formula, what are your a, b, and c values? Okay? Remember, quadratic formula wants a x squared plus some bx plus some c value for a standard form quadratic. This is a standard form quadratic. So we can read now that a has to be 1, b is 12, and c is minus 6.25. Okay? Okay, so let's actually use the quadratic formula and solve this now. Okay, so again, quadratic formula is something you need to know by heart, need to be comfortable with. The quadratic formula will solve quadratics and yield up to 0, 1, or 2 solutions. And I'm just writing it out here. Remember, solutions, another word is roots, another word is x-intercepts, and another word could be zeros. So, okay, so I'm going to start replacing my a, b, c values from my standard form quadratic into the quadratic formula, and let's solve this. Okay, so notice in here, minus 12 plus or minus the square root of all that. Here we're going to have a positive number because we're squaring 12. And then the negative symbol here and the negative symbol here is going to make a positive number out of this calculation. And inside the square root, you're going to have a positive number. That's good. You're going to actually have solutions. If you had a negative number in the square root, you'd have no solutions. It would not be solvable. You'd need these things called imaginary numbers, which we don't discuss in this course. Okay, so let's keep solving. Minus 12 plus or minus, what is that, 144, right, plus 25 if you work that out, over 2, keep going, minus 12 plus or minus square root of 169, okay, over 2. Okay, so we have 2 solutions. X can equal minus 12 plus 13 over 2, or okay, keep going. Minus 12 plus 13, 1. It's a half. Or x can equal minus 25 over 2. So remember, x we defined earlier is that border width for our flower garden. And well, think about that. Think about these answers. You have to do this because we'll never give you questions that make that end up with answers that make no sense when it comes to real-world applications. It's just pointless to do that. We'll give you numbers that make sense. So if x is a half, and we were dealing with this flower garden, and it was measured in meters, so that's half a meter. That's very reasonable, half a meter for a flower garden. What about this number? X is minus 25 over 2. Well, guys, minus 25 over 2 for a distance, or for rather a width of a flower border, it just makes no sense. It makes absolutely no, you can't have a negative width. So what you do with this answer is you actually say it's inadmissible. It's inadmissible. Okay? So the only possible solution we can use out of the two is x equals a half. And that's a solid number. It makes sense for this application question. And you're able to basically tell us now, in your final sentence, the border width is a half meter. So lawns flower garden border width is 0.5 meters. Now make sure you're putting units, okay? I mean, let's go over where we could possibly get points deducted for these types of questions, okay? Just make sure you're defining your variables, okay? Especially the one that you're actually going to solve for. Let x be the border width, all right? Use good steps. Explain your work, show all the lines, so if you do make a mistake, we can still give you part marks, all right? So you had your area that was given, you found the difference between the two, you used FOIL, you collected all your terms, you moved the right numbers into your quadratic formula. Okay? It's all well laid out. Circle your x answers, your solutions. Tell us it's inadmissible if that's the case. Use your judgment. Half makes sense, and negative width doesn't. And then conclude with a sentence, okay? Answer the actual question. Milan's flower garden border width is 0.5 meters. Okay. Alright, well I hope this helps, and look for more videos. Thanks, Mr. Quenneville.